Thank you all for joining today. My name is Serian. I work for CopperTree Analytics. What I'd like to just discuss with you guys today is how to integrate fault detection and diagnostics into a monitoring-based commissioning program. So the first thing is I really like these sessions to be interactive, and I try not to look at the PowerPoint, and I really want to make this worth it for you guys. So I really want to encourage questions and more of an interactive session, and so feel free to grill me at will, because that's where it gets interesting, right? Okay, so essentially what we're going to talk about today is what is fault detection diagnostics, and how does that software integrate into a building, and how can we apply that to a monitoring-based commissioning program. So just a quick show of hands, who here knows what a rule is? Okay, looks like about 30 to 40%. That's usually kind of what I see when these presentations. And then who here is using fault detection and diagnostics as part of startup commissioning or as part of ongoing commissioning? Okay, even less, it drops down a little bit, so maybe about 5 to 10%. So that just kind of gives you guys a flavor of where the market is today. Just my view is I'm starting, I see this kind of ramping out of the early adopter phase and really starting to pick up steam. And so hopefully today can be worthwhile for you guys. So this is what we're going to talk about. We're basically going to discuss how to use this concept of rules in different ways, right? So whether it's KPIs or virtual metering or just standard fault detection, how can we apply this concept to basically streamline your commissioning process and basically provide a better service than using human labor today. All right, so this is just a basic idea of what a rule is. Essentially, it's a number of discrete algorithms that are operating continuously in the background as data from a building automation system is getting fed into these algorithms. So when you think about like an example of one of these algorithms, it's basically going to be things that you're doing today as part of your functional test procedures during commissioning. We can mimic a lot of that using these algorithms. And so instead of doing any of these functional test procedures in a statistically valid sample in a building, and then extrapolating that out to the population and saying, okay, check. We can now use rules analytics to look at the entire building 24/7 and provide a better result for that specific rule. And so what's an example? So let's just look at a simple example, an air handling unit. How can we apply rules? And how are we different from a BAS alarm, more importantly? Right? That may be a question for the 60 to 70% of you who haven't heard of a rule yet. So the first thing is, if you have a BAS alarm, right? In this example, let's say it's, Orlando's not the best example. Let's say it's Chicago in the middle of winter, and there's a very large convention space, and this is just one of those air handlers. And let's say there's no one in the room, right? You don't want to bring in outside air. It's the middle of winter. You want to bring in either a minimum amount or no amount, right? And in this example, there's no BAS alarms triggering, right? The zones are happy, the occupants are happy, and all is peachy, right? But what rules and fault detection can do is look at interrelationships between control points and then give you more insight than you can get from a conventional BAS alarm. So in this case, all we're going to be looking at is supply air temperature, return air temperature, the dimmer position, and we're going to look at a longer period of time, right? So a BAS alarm is focused on, typically focused on an instantaneous point in time, and it'll consider one or more inputs, and it'll trigger, right, if a condition is met. What we're looking at are repeatable systemic issues in the building that an alarm just can't provide. And then we're deploying that across all the building systems at scale. Typically when you set up an alarm, it's for a single system, a single building system in a commercial building. The rules, if you choose the right software package, will deploy across all the building systems in a very scalable, seamless way. And so in this case, if we see a difference between the mixed air temperature and the supply air temperature when that damper is supposed to be closed or at a minimum position, then we want to flag that and bring it to your attention, right? And let's say this is happening repeatedly throughout the week. Well, you might have a leaking outside air damper. It's very possible. And so this would be an example. And if you had a minimum that you wanted to set, you can even increase your, the difference between your mixed air temperature and supply air temperature to account for that minimum and still provide you the value that you're looking for. And so this is an example of a rule. And for when these rules do trigger, there's typically going to be anywhere between 1 and 4 recommended actions, right? Because the information alone is helpful, but you really want to know how to fix the problem, right? That's ultimately where you're going. What's the impact of this problem and how am I going to fix it? Or how can I work with the customer to fix it? So that is another very typical part of giving you an insight like that. So what are the kind of things that we're finding? We're not in the business of finding your chiller replacement or your lighting replacement, anything that we would classify as low-hanging fruit that you can easily find just in a walkthrough. We're finding the stuff that just takes too much human labor to find at scale in a building. And you might be able to find this stuff, in a sample of building systems, either pulling trends off the BAS, deploying data loggers, walking through the building, looking at a BAS graphic. But at scale, it's just not possible, especially at the larger buildings, right? So we're going to go through a couple of case studies, and we'll sort of highlight along the way how this can be applied. All right, so in this example, it's a space. There's every 15 minutes you're getting the data reported to you on the room temperature, and actually what's happening is over that 15-minute period, the average room temperature is getting reported. And if you can see here, it looks okay, right? No issues. And there's no alarms triggering, but the occupants are complaining. They're saying, it's hot, it's cold. There's a problem here, but there's no alarms triggering. No one really knows there's a problem unless the occupants are complaining, which they are in this case. So if you kind of open up the hood a little bit, in this example, there's actually a lot of fluctuation in the supply air temperature coming out of the VAV. And also the hot water valve on the VAV box is also, the temperature is also fluctuating quite a bit. So if you kind of track this, kind of go from downstream all the way to the upstream portion of the system, in this example, the problem was the boilers were actually supposed to be lead lag, but they were stopping and starting together. They were overshooting the supply water set point, and that's what was causing that downstream problem. And it was notified using rules that it was actually an occupant complaint, but we actually were able to track this problem down, and the result is, and this is not every rule is going to give you, a benefit in occupant comfort, a benefit in maintenance installer, and a benefit in energy. If you can get all three, that's pretty impressive, but usually it's going to be, a combination of those three. But in this case, you got an improvement in occupant comfort, you saved wear and tear on your boiler system, and you have energy savings, right? As a result of operating your plant more efficiently, as it should have been operated to begin with.
So for that example, what you could do is set up a rule. One of those rule categories was sequence of optimization, right? So if you design the rule to look at a boiler system and say, this boiler system should be operating like this, and that could be per the ASHRAE design standard or just per how the building should have been set up to begin with, you get notified about situations like this without having an occupant complain or without having to investigate it in real time or reactively. Okay, so that was like a sort of a simple example. This next one is focused on a building with BACnet. So BACnet offers the ability to give us some more insight on a specific control point. The BACnet object settings. So the way we can leverage this is if a schedule gets changed, if a set point gets changed, after you guys go in and commission a building, then we can notify you of that change through, CopperTree calls it golden standard. Essentially, you take a snapshot of the BACnet object settings after you guys do a startup commissioning, and then if any of those settings gets changed, we can notify you of that. We can even prioritize those changes, so you may want to only get notified if a specific category of changes was made, like a schedule or a set point, and then some of the other changes you may want to have as a lower priority, and you can triage these sorts of changes from that baseline state accordingly. So why, how can this be of value? Well, it's pretty clear, but you could have the systems operating 24/7 and not even know about it unless something like this was brought to your attention in the form of a rule where the condition of that rule was met. So this is just an example looking at occupancy and energy consumption, and just showing you that it was in line, energy and occupancy was in line and then drifted, and something happened, right? And unless you get a report of a setting that was changed by perhaps a building operator, you just wouldn't know about this. And if the problem drags on long enough, then it could be thousands and thousands of dollars of energy waste. So just another example, one of our clients, it's a hospital system. They had a helicopter pad with a de-icing system that was electric resistance, and it was actually overridden. And it was operating during the summer. We caught it using golden standard, and just in 2 months, huge impact on energy consumption. That, I mean, who's going on a roof and really checking this stuff? Or, it would take a pretty astute person to find a lot of these things without it getting reported to them. So that's just another example of how golden standard can be applied. Virtual metering is my personal favorite. I come from the energy world, so I really like virtual metering. So basically, and this is all in the category of rules, right? We're just applying rules in different ways. So virtual metering, basically, it doesn't require you to install physical submeters in a building, where a physical submeter isn't really feasible from a cost perspective to install. So all we're doing here is we're applying the same industry standard equations that you guys are doing in Microsoft Excel, except we're embedding those within rules. We're mapping inputs from the building automation system to some of these points, and where there isn't a point in the building automation system to leverage to create this virtual meter, we're just putting in constants. Things like three-phase voltage, power factor. Those points are typically not a control point in the building automation system, but you still want to know how much energy this system is consuming, and it may not make sense to install a submeter. Things like a supply fan motor, a pump motor, even a VAV box, anything with BTU or kWh output. So that's what essentially virtual metering is. Now, of course, it's not as accurate as a physical submeter. There's no arguing that. But for doing things like apples-to-apples comparisons, what do I mean by that? So spotting anomalies in energy use. So we can look at these virtual meters, set baselines. We could even weather normalize those baselines. This is all using rules, by the way. And then we can notify you if the daily or weekly consumption of one of these systems is higher than it should be. Normalized for weather, even. And so that's valuable, right? So if you're trying to commission or provide an ongoing commissioning service, that's valuable information. The other really cool thing is we can stack virtual meters on top of each other. So think about having the energy consumption of just an air handling unit itself broken down between the heating cooling coil and the supply and return fan. Or a chiller plant that is broken down between all the components of a chiller plant that consume energy. So that's leading to the next use case, which is going to be measurement and verification. So this is option B IPMVP certified as a means to do measurement and verification. So if you guys are in the business of providing energy services, whether you recommend an energy conservation measure that the client moves forward with, and then you want to work with that client to show them how much they're saving, we can do that using rules and virtual metering. So as long as we know when the project was implemented and we have data before that project was implemented, we can show them the realized energy savings for doing a specific project. And that gets updated continuously, right? That's the difference between handing a Microsoft Word document and saying, here are your savings. This is going to update continuously, right? Because the data from the BAS is coming in continuously. So there's benefits there. So this is just an example of using virtual metering. In this case, we have the supply fan energy use, a virtual meter created for the supply fan in an air handling unit. And another example, there's no occupant complaints. The operators were unaware of any problem that was taking place. But there were a couple of rules that triggered in this system, actually downstream at the VAV level, that the VAV dampers were open more than they really should be, per the design spec. Tracing it back, it ended up actually being an exhaust air damper where the electrical signal to that exhaust air damper was essentially malfunctioning, and the pressurization in the air handling unit was so low that the supply fan was ramping up to 100% and the VAVs were opening up too much over time. And we wouldn't have known this unless the insight or the rule was brought to our attention. And so you could see that in this example, not only, the problem was there, they're basically using way more energy than they should in the supply fan. We found the problem using the rules and then fixed the problem. And, just a simple problem like this can be thousands of dollars in savings. And this can just be one piece of a larger project that you guys are doing, and it all adds up. Okay, KPIs. All right, KPIs are really great to use when you have a lot of one thing in a building. So what comes to mind? Yes, VAVs, exactly. So air handling units, VAVs, think about startup commissioning for VAVs. You guys or you may be going in, doing combination of physical inspection and data analysis to determine if a VAV is functioning properly. If it's a larger building, you're likely not getting to look at all the VAVs, right? And you're taking your sample set, your statistically valid sample set, and you're saying, all the VAVs are operating as they should. Well, KPIs can do this in a much better way. So we could look at all the VAV boxes, and we could focus on temperature, airflow, hot water valve position, or a combination of all three, and then tell you which VAV boxes aren't performing as they should. And now you can just get a report that tells you, focus your attention on these top 10 or these top 20 VAVs. The other ones, they're operating as they should within design spec. So typically how it works is there's a set point and there's a deadband around the set point that's configurable. And as that measured variable kind of floats, we're gonna actually quantify the percent of time that measured variable is outside of that deadband. And then depending on the time period of interest, it could be daily, it could be weekly, we're gonna report out to you how well this system is performing. And so you could see in itself, this is very much different from a BAS alarm, right? We're looking at a longer period of time. We're trying to find a repeatable problem. And this is just another example of rules, right? Where the inputs are gonna be coming from that VAV box and the outputs are gonna be a score, right? It's gonna be a score of 0 to 100 on how well that's performing. So this is just an example, and you guys can see like the amount of data that we're working with here is huge, right? You know, it's millions of data points, and this is just for a VAV system. And this is an example where we applied KPI rules for zone temperature, right? So you may be focused on zone temperature, and you can get a list of, you know, the zones that aren't performing, or you may be focused on airflow, right? And the same concept applies. You can get an idea of which zones aren't providing airflow correctly. Same thing with reheat energy. In this example, we were looking at all three. And what we found was, you know, only a small percentage of the zones were using most of the energy. So what can you do with this? Well, we can do a weighted average of those three, you know, whether it's reheat, temperature, and airflow, we can do a weighted average of those three and just give you one score. Or you may want them independently, and you may want to cross-reference and find the VAVs that are, you know, a combination of all these three parameters are performing the worst. And then you could target your remediation on those systems. Okay. Before I get into this, is it okay if we stop for some questions? All right, well, I guess I'll just say yes, it's okay if we could stop for some questions. So I like to just, before I get into this, I like to just open up the floor for a couple of questions on just what I talked about, whether it's rules, virtual metering, fault detection, and love to answer some of your questions.
So virtual metering, does that qualify for some FDD protocol or specifically for the protocol moving?
It does. So we are, you know, there's a couple of utilities that we are approved for, both in US and Canada for using virtual metering for M&V. It's if you look at the FEMP IPMVP standard, option B, it also qualifies using virtual metering as a method to quantify savings using that option B protocol. And also for P for performance programs with utilities as well. So utilities love that because they just, and what we do typically is we'll set it up in a report. So we'll create the M&V rule. It'll update continuously and quantify the savings. And then whether the utility or the partner who's reporting to the utility wants a report sent to them, you know, weekly or monthly, which is, hey, give me an update on how much this is saving. That's entirely possible with tools like this. The other really cool thing is savings persistence. So just in the same way you can quantify how much you're saving, you can even set up rules to notify you if the persistence of savings drifts from its target state. So now you can get a notification that says the energy savings on my static pressure reset strategy is 20% below the monthly moving average, right? Something like that, you can get notified. And so you don't have to, you know, your client's like, hey, is this project saving me energy I thought it would? Well, you can have all that stuff automated and reported to you. And if it is a problem, you would get notified about it. Maybe in the back first.
For your rules setup, are some hard-coded or is it a user-accessible parameter to set the trigger that's after the initial setup? So somebody's in the building, you can make your example where you're like 2 degrees is constant usage.
Yeah.
And I'll judge that at 5 degrees.
Right.
That's an easy
Yes. I mean, every tool out there is different, but CopperTree, we have a block diagram style programming language that, and we are partner driven, so we work mostly with partners and they want the ability to do that, whether it's just changing thresholds, or you may want to actually go into the logic of the rule and modify it or add to it. That's all very possible. Yep. Okay, there was a couple here. You want to go next?
How do you connect and communicate to a BA system?
So there's a,
Repeat the question.
how do we connect and communicate to a building automation system? That's a great question. So there's a number of ways because we have to be flexible in this industry, right? There's commercial buildings, cookie cutter is like not part of our vocabulary, right? So we can either pull the trend log data from a SQL server or any kind of historian. That's one option if the trend log is already set up. We also have an edge device that would sit in the building and it actually does the trending on its own. So, especially if you're an engineering firm and you don't want to have to tap on the controls contractor's shoulder to, hey, can you set all these trends up for me? Our edge device actually can do the trending itself, and what it does is it pulls all the exposed control points, and then every 5 minutes a batch of data gets sent to our cloud. We are a cloud-based solution. There's also tools out there that are more focused for on-premise. We are a cloud-based solution, so that's how we get the data. Generally speaking, it's either one of those two options. Please.
I like the idea of virtual meters for individual pieces of equipment, but the accuracy of such a meter is dependent on a bunch of temperature sensors that typically aren't calibrated. And so, can you speak to the idea of relative delta T, for example, as opposed to actual close calibration or matching calibrations?
Sure. So we have a category of rules that are set up to call out faulty sensors. So, and again, every tool out there is different. Some FDD solutions, they'll have a set of rules, and then every building gets those rules, right? We're a little bit different. We have a library of rules that we can kind of deploy down into buildings depending on what's in the building and then what your goals are. And so faulty sensor is like a very basic rule that we can report on, and so you would get notified if that was the case. Essentially, when you're thinking about using virtual metering and you're questioning the reliability of the data, we could set those rules up, those faulty sensor rules, so you can get notified about that. But it's important to distinguish that sensor calibration is not something that we can do. So, when I talked about mimicking your functional test procedures using rules, that is not for everything, right? I mean, you guys will still need to go in the building and do the calibration. We can't do that. We would rely on the partners to make sure that that's in place. I mean, we could tell you when things aren't operating as they should, but there are limitations on what a tool like this can do, and calibration is one of them. Did that answer your question, or? Okay. Somebody over here, maybe? Please.
You mentioned just briefly the Kaizen Golden Standard.
Uh-huh.
What is that?
So Golden Standard, essentially all we're doing is we're taking a snapshot of all the BACnet object settings in the building automation system at any given point in time, and typically that's going to be after a building is commissioned. And then when any of those BACnet object settings change, we would report that to you. Things like schedules or modes of operation going from automatic to manual mode. We would report out to you. So that's what Golden Standard is. The Golden Standard is that baseline. And then let's say a schedule was changed and you're okay with it, you can actually promote that to the new Golden Standard, and that becomes a new baseline. And then we would notify you if it changes after that. So it's just an ongoing commissioning feature.
Do end users and O&M staff have real-time access to this data, or do they have to wait on a report back from?
Sure. Yes, they can have access. So it could be read-only, read-write access. I mean, you might want to just give them a read-only account so they could log in and look at the dashboard, look at the insights. They can also get subscribed reports delivered to them. If you don't want them to have access. Every partner is different in what they really want their customer to have exposure to. But a combination of reports, access, or one or the other are possible.
Making an assumption that there's equipment that you have to add to the building, right? Like a copper cube,
Well, yeah, in terms of the edge
How are you
device.
going to extract the information?
Yes, there is an edge device, correct, yes.
And if we were going to do, if anybody wants to do that, there's that cost, right? That they would have to either incorporate, if it's a retro commissioning, into that part of the project, or if it's a brand new project. And then I'm making the assumption that there is some charge for you to do behind the curtain stuff for us.
Sure. So our edge device it's actually a very low-cost piece of hardware. It's the drivers and the software that we deploy onto it, depending on the protocol, whether it's BACnet or a legacy protocol. The hardware is actually very inexpensive, and you know, and again, every software company is out there is different. Some provide just the software, and you have to set it up. We kind of do one or the other, so we could set the buildings up for you, or you can set the buildings up. And the edge device is just part of the implementation cost, and it's really negligible when you consider labor hours to set a building up.
So back to the sensors, you alluded to it. Say the building is 5 years old, you go in, you require the sensors to calibrate it off the get-go, do you recommend that?
We don't require it, no. I mean, we get brought into existing buildings quite a bit. And the rules that we would put onto a building are just, if it's focused more on maintenance, like you're saying in this category, then we would deploy those rule sets to identify those types of problems. But some people just are focused on energy, and they just want us to find energy savings. So it just depends on the client, but we don't require anything. I mean, this technology is at a point where, you know, we can't really require anything, right? We just need to get into the market, show the value of a tool like this, and then maybe down the road we could start to put those requirements out there. But yeah, it's just. Good question. Yeah, work order integration is a good question. So there's a couple of ways that we go about that. We have a built-in what we call insight management feature, because this stuff is great, but if you don't know how to embed it into your workflow, it's just information, right? And it can become difficult. So we have a built-in workflow management tool. We also have a JSON, a REST API that we can essentially port our insights into a work order management system like a CMMS tool, and that's sometimes used. But it's important, right? Because this is just an intelligence platform. You know, we're not controlling the BAS. You know, this isn't automated system optimization. This is FDD, and we're providing you guys with information. So integrating it into workflow is very important, especially if it's for an end user that's using it. Partners are a little bit better. They're more flexible, and so if you guys don't have a work order management system, you can use ours, or you can suck our insights out and embed it into another platform that's API accessible. Okay. All right, well, is there a time check we can? Okay, great. All right, well, I'll kind of keep going here. So essentially, you know, what this is about, and this is going to just so you guys know, this is common sense. I'm not going to present anything here that's new and different. This is essentially how you can take a tool like this and embed it into a program. In a simplistic sense, you know, you basically want to apply FDD to whatever is set up, identify the issues, prioritize them, and then fix them, and then report on those savings, and then rinse and repeat, right? And I'm sure you guys have seen that kind of workflow before, right? It's nothing new. But if you think about how you, like, who here is really interested in starting up ongoing commissioning as a service offering, but is currently just offering startup commissioning? Okay. All right, so about maybe 30%. Okay, so essentially how this can work in real life is during startup commissioning, you would drop a system like this into the building of interest. We would assist you in doing the startup commissioning through mimicking as much of your functional test procedures as possible using rules, right? That would assist you during your startup commissioning. Then we would stay in the building, and it could be for 1 year, it can be for 2 years, but that's where you would segue into an ongoing commissioning service, right? So if a customer just wanted, standard startup commissioning, and then you guys walk away, they can do that. Or if you want more of an analytics-driven commissioning program that's ongoing for, let's say, a 1-year warranty period, you can do that. I mean, really what this does is it enables you guys to stay in buildings versus getting in and getting out. So just to kind of get in a little bit more detail here, essentially you want to collect as much data as possible. In terms of setting up the infrastructure, some tools out there require you to put a gateway in or a JACE to get the data to their tool. It all depends on who you work with, but that is one of the Achilles heels of the industry, right, is getting the data. And then once you get the data, you got to make sense of it, right? You got to map all that data to whatever intelligence platform you have built up, and that's another challenge in itself. So, in terms of tracking and reporting and taking action, you guys really want a way to show your customers that you're doing the job that you say you're doing, right? Versus just giving them maybe a Word document, a report saying, we did these checks and everything is falling in line. So the way that we could set rules up to do that is there's reports that we can deliver that can even create like a system-wide KPI score for all your systems. Let's say you're looking at all the VAVs in totality or all the air handling units in totality, and you want to create like a system-wide KPI score, and then you want to be able to track that over time and then show them, maybe through this ongoing commissioning program, how you guys are doing, right? It's a measurable way of showing your value to your clients. And so if you guys get into a building, maybe it's through like a retro commissioning program, and you deploy a software tool like this, and it's showing a KPI score of all the VAVs or all the air handlers of, let's say, 40%. And that would be a combination of all those pieces of equipment into one number. Okay, so you guys start working in the building. The next month it may pop up to, let's say, 60% and then 70%. We can actually create reports that show this to your customers. So FDD is also good for demonstrating the results of a commissioning agent to your customers without any other means to do so. And it will also encourage them to invest in the solution and to continue to invest in the solution over time. Okay. So that's all I really wanted to talk about. I'd love some more questions if you guys have them.
If the owner of the new building construction is a user, then you have to make a decision to use this product to the design. Then does the decision have to be made to be able to use the product?
So for new construction, the key is really getting put into the spec, the design spec for that building. So it's educating design engineering firms and showing them what a tool like this is, and then encouraging them to include it in, even if it's an optional scope item, right? But including it in the spec, so it gets deployed as part of the new construction process, because it's in actually the RFP or the design spec.
Would you have that available to us
Mm-hmm.
on email or website? Or
Mm-hmm. Yeah, we have that. We have like a sample technical spec that, our partners just basically insert.
Do we contact you or do you contact?
Yeah, you can contact me or, yeah, that works. Okay, we got two over here. All right, awesome.
Where we have some of the EAS systems, sometimes backnet, the boiler system controller, and all the BAS does is notice an alarm.
So those points are getting pulled through to the front end?
Right. How do you pull that information in? Because those are obviously two systems.
Yes, that's a good question. So sometimes, so the question is, you know, sometimes you have packaged equipment or sometimes you have building systems that may not, those points may not be getting pulled into the front end, which is what our, you know, which a lot of these edge devices are relying on, is that central warehouse of data. So in that case, you know, the way we would do it is we would actually deploy our edge device on the specific controller of that piece of equipment, whether it's a chiller plant, and you know, we could talk LawnWorks and Modbus and those protocols. So we would just put an edge device specifically on that, and then we would also put an edge device on the BAS, and then it would just be two data streams that are running up in parallel into our platform. So we would virtually combine them in our platform. You're welcome. Did you want to ask a question?
In terms of like getting access to the data, where do you see the trends going? Are they building the BAS system so that in the future you're going to see a standard that will allow you to get that data pretty easily? Is that trend?
Yeah. So you know, even so, it's just south of 50% our buildings still have legacy protocols, right? So you know, if you can't talk to them, which most people can't, you're basically at the will of the controls contractor. So buildings are moving into BACnet for all new construction, any kind of renovations, all going to BACnet. Another popular thing is putting in a Tritium front end that will communicate with the legacy system and then provide sort of an open source way of getting the data and talking to that equipment. So that's where the industry is going, right? And that's going to enable providers like CopperTree to provide services in those buildings, and that's basically been another Achilles heels of this industry, is getting the data, because there's so many different vendors out there. They each have their own protocol. You know, I'm talking legacy proprietary protocols, and BACnet is fixing that problem, thankfully.
How is the data being transferred out of BACnet? XML, or is there a standard for getting that data?
For getting that data? Yeah, so you know, that's where we would have our edge device would basically talk to the building automation system, and it would pull in those BACnet points, sample them, and then basically push that data into the cloud. So we're not really converting it at all. We're just leveraging it in that existing state. Yeah.
How do you handle security so that your platform isn't a backdoor to the client?
Yeah, that's a great question. I think I'm overusing the term Achilles heel, so I'll just stop saying that. But that's another problem with the industry, right? Especially cloud-based solutions. We aren't an on-premise solution, so IT security is something we have to work with, especially with IT departments that are very risk averse, right? They're incentivized to not have us in a building versus have us in a building, right? So that's the challenge that we're up against. The good thing is we have close to 2,000 buildings. We've never been hacked before. We've never had a cybersecurity issue. Yeah, but then Target will have a breach, and then everyone will get up in arms about it. And my view on this problem is similar to driving on the highway. You drive on the highway knowing you can get hurt, but you're assessing probability, right? And you're making that decision. I think that's sort of what our industry is facing today. Is we just don't know what that probability is. We don't know what that risk profile is. It's all very new, and so the gut reaction is just to not allow it, because you don't know what the risk is, the probability of that problem happening. So our edge device is passive. There's no way of getting into it. The data transmission is SSL encrypted. And then the platform itself that we operate on is on Amazon Web Services, which is FedRAMP certified. So for those of you who haven't heard about FedRAMP certification, it's a government certification that, basically the government's saying, we know cloud-based tools are the future. We need to find a way to make this work. So Amazon Web Services is a FedRAMP certified cloud platform to operate on. So technically we can work with government agencies if you adhere to that standard. So I think the industry is moving in the direction of allowing cloud-based tools, but it's definitely not simple. And the other thing is it's so decentralized. Everyone has their own opinion on how this problem actually, or how big of a problem this is. So that's part of our deployment, is we have to always talk to the IT department and just tell them how we do it, get them on board with it. And if they're open to cloud-based tools, we've never had a problem. But there are some clients out there that say, I don't even care what your tool is. If a bit of data is leaving this building, it's not allowed. So there's ways we can get around it. So we can deploy like a virtual machine into the building, deploy our software onto that virtual machine that then pushes the data out. Or we can actually operate in a DMZ, which is called a demilitarized zone. It's essentially like an air gap or a middle network layer that we can extract the data out of. But no matter how you cut it, the data is still leaving the building in some format. It's just how that happens. So we're very flexible. I mentioned before that cookie cutter solutions are just not in our vocabulary because we have to be flexible for reasons like that.
If we wanted to deploy this for, let's say, a couple of months where we want to do an analysis for an energy audit, is it possible to do that? Or is it cost prohibitive?
Couple months is, I would say 6 months would be the lowest, the shortest time period. We take about 4 to 6 weeks to deploy. So for 2 months, that wouldn't make sense. We've done 6 months, and some people actually will put us in for 6 months and then move us to another building because they may not be interested in the ongoing commissioning. They just may want to use us for the startup commissioning. So yeah, I would say anything less than 6 months just doesn't make sense. But typically it's 1 year would be the typical license period. Okay, all the way over here. All right.
Due to the fact you're cloud-based, you end up aggregating the data, comparing buildings to other buildings, and seeing how you might compare to a building in your geographic location maybe.
Yeah, that's a good question. So the question is, we have all this data from buildings in our platform. Are we doing analyses to leverage all that data in a portfolio manner to basically improve our product? And the answer is yes, we are doing that internally. Our use agreement, we can't provide that to any third party as a means of marketing or resale. But we do use that data as a means of improving our rules, our product. And that is actually the benefit. Another benefit of being cloud-based is having that massive data set to work off of. So we can understand, so just to take that a step further, we can understand trends in buildings. So if we're deploying certain insights or rules in buildings, and we could start to see the results of how those rules impact buildings and how those rules actually trigger in buildings, and then bring that up to the portfolio level. So it's very helpful doing analyses like that, yeah. Okay. How about someone on that far end? I'll actually run over there this time. Just kidding. Anybody else?
Expanding on the question asked a moment ago, if you're using this platform for new building construction, my experience is that most of the time that building management system isn't even fully set up until just before you want to start testing. And so then the time frame becomes pretty compressed.
Right.
So, like you were suggesting, I think that it's a useful tool
Sure, sure. So, we take about 4 to 6 weeks to set up from, start to finish. And so that has to be considered, right? So within your budgeted timeline for doing startup commissioning, that would have to be considered. We would just be part of your Gantt chart of how this is going to roll out. And then the idea is that we would just stay in the building after that period, and then now you guys can have a way to stay in touch with the customer and create more of a recurring revenue stream and ongoing relationship. So that's basically how it works. And whether it's startup commissioning or ongoing commissioning, it's the same thing. You're just doing it continuously, right? So that's why a tool like this can be beneficial. So you're not in and out, and you're with the customer, and you're continuing to provide that service as the system becomes out of tune. Okay. Any questions? Other questions? Am I too early? Are we okay on time? Okay. All right. All right, well, thank you guys.